Hi, this is Jason Clark here at South Dakota State University. Welcome back to our webinar series on nitrogen recommendations for corn here in South Dakota. To this point, we've talked about our yield goal recommendation system. In this video, we're going to go over how accurate our system has been over the last several years. So in this research, we've had 21 nitrogen rate research sites from 2018 to 2020. In this presentation, we have a lot more that are upcoming, but in these sites, we have 13 that were conventional till, 6 were no-till. Previous crop, majority of the time is soybean, the other times it's been wheat. If we look at the location of these sites, we see in the north central area and the east is where most of them are. However, we do have a lot more in this part of the state. We just haven't gotten them into the database yet, but we hopefully will soon. So in each of these different research sites, just to show you what we did to determine our fertilizer recommendations, our accuracy, what we did for each of these sites. This is an example in Salem, South Dakota. So we take our corn yield goal on our y-axis, and then we have our nitrogen fertilizer rate on our x-axis, and we have 6 different nitrogen rates, and we see how as those nitrogen rates increase, how corn yield responds. So we see that here. As we can see, we tend to see an increase in corn yield as nitrogen fertilizer rate increases. However, at some point between here, we then see that we see no more increases in yield. So what we want to do is we want to determine at what rate between nitrogen rate between here and here do we see no more yield. We don't have any nitrogen rates between these 2 points, so we have to do some math. So there's a couple ways to do this math. One way is to do a linear model. So we have a linear line until we think that it goes flat. So that looks like this. So it'd say our optimal N is right here, just below 100 pounds nitrogen per acre. And we can do a quadratic model where it's increasing at a decreasing rate until it hits its optimal yield. If we do that, same data, we see that that line flattens out a little later, around 120 pounds nitrogen per acre. So we look at the math, both models end up yielding the same amount. Both models are just saying different requirements as far as nitrogen goes. So which one's correct? Kind of depends on your opinion. In South Dakota, we normally use the red model versus the blue model, but somewhere between the two is probably the most correct answer. Now if we look at each of these 21 sites that we have in this data set and we see what nitrogen rate they needed to obtain optimal yield versus the yield that they obtained, we'll see that in this graph here. So if we look at the nitrogen requirements to obtain optimal yield, we saw that it varied quite a bit. We have these 7 sites down here that didn't respond to nitrogen, and it might be for various reasons. Some had drought issues, some had too much water, but some just didn't require it. And what we need to do in future studies is be able to better identify what it is about those sites that results in no nitrogen being needed to obtain that optimal yield. So one other thing we can look at is if we look at the yield at these optimum N rates, we don't see a similar trend like we see here. Just because we needed more nitrogen doesn't mean we actually yielded more. Our yields varied quite a bit. Whether we needed 38 to obtain 188 bushels or we needed 95. So then the question is how accurate is our current yield goal system? So you've already seen part of it, but just as a review here, this is our nitrogen fertilizer recommendation system here. So in order to determine the recommendation, we take our yield goal, multiply it by 1.2, subtract our soil test nitrogen value, subtract our legume credit, and add a no-till debit of 30 pounds per acre if we're using no-till. So this is our recommendation system, the equation that we use. How accurate is that? So we're going to take these 21 sites, we're going to do each of these steps. We're going to take our yield goal, multiply it by 1.2. This is our total soil test nitrogen we need. And then we're going to subtract our soil test nitrogen from that value. Then we're going to subtract our legume credit to those sites that needed it. And then we're going to add that no-till debit to those sites that were in no-till. So this right here would be our recommendation for each of these 21 sites. So now we're going to look at that recommendation versus the actual nitrogen need. So here again, recommendation. Now this blue line is going to be our actual nitrogen needs. The closer these two lines match, the more accurate our system was. So you can see sometimes we underestimated nitrogen, sometimes we were right on. These sites over here, we were right on. On these sites here, you can see that we overestimated nitrogen. So now one thing we're going to look at that we have a lot of questions about is this 1.2 coefficient. And if we remember, this 1.2 coefficient is determined by taking our soil test nitrogen, our fertilizer N, dividing it by our bushels per acre, and getting this 1.2 pounds of nitrogen per bushel of corn coefficient. However, in recent studies, we've seen that that 1.2 line that you see here, on average, is actually a little high. In reality, that average is closer to around 0.7, but if we take around those sites that are X that didn't respond to nitrogen, our average then is around 0.9. How accurate is our current recommendations if we use 1.2 versus if we lower it to 1.0 or if we lower it to 0.8? And that's what we're going to find out right now. So here the sites that are X'd are the sites that didn't respond to nitrogen, so they might be a little iffy. And here we're looking at our nitrogen recommendation using that 1.2, 1.0, and 0.8 coefficient and see how different it is from our optimal nitrogen fertilizer rate. So if we look at our 1.2, those numbers above the line say we're overestimating it. Those numbers below 0 say we're underestimating that recommendation. So this is using our current system. Now what if we lower that to 1.0? We see that a lot of these sites, they get closer to 0. In some sites, they can move farther below the line. Now if we lower that even more to 0.8, we see that in most of these sites we're getting even lower, even closer to 0. However, we're underestimating in some sites even more. So these sites where we tend to be underestimating, as we lower the coefficient, we tend to underestimate even more. However, these sites right here, which is the majority of sites, where we're overestimating with the 1.2, we tend to be getting closer to 0, which is what we want. So in this next slide, what we're going to do is we're going to group these together. We're going to group those sites that tend to underestimate, those sites that overestimate a lot, and then those sites that are majority of the sites that are somewhere in the middle, and look at what they do. So first of all, those sites that tend to overestimate. So again, we're going to see closer to the line, more accurate. So use that 1.2 coefficient, we tend to overestimate 157 pounds of nitrogen per acre. It gets closer to 0 as we move to 1.0, even closer to 0 as we move to 0.8. So we can see in those ones we tend to overestimate, lowering the coefficient is really helpful. Now in those ones we tend to underestimate, we see the opposite pattern. We see as we move from 1.2 to 1 to 1.2, 0.8, we tend to underestimate our nitrogen needs even more. However, the most important section is that mean 50% in the middle. This is the majority of our sites, what most happens most of the time. So here we see we tend to overestimate by 64 pounds of N with 1.2 coefficient. And as we lower that coefficient, we get closer to 0. That 0.8 actually gets us past 0, so we're underestimating a little bit. So the answer might lie really close to that 1.0 to 0.8 difference. Now if we want to look at this data a little bit differently, we can see it all grouped together. The boxes represent that 50% of the data. The X and the line are the mean and the median. The lines above it, those whiskers, are that 25% above the mean, and then the below is 25% below the mean. As you can see here, we tend to get closer to that line as we go from 1.2 to 1.0 to 0.8. So it's really important to note that as we're lowering it, we're getting a majority more accurate. So in the future, we're likely going to be seeing this 1.2 coefficient likely decreasing. However, we're going to get all this data together and a few more years of data before we fully change the recommendation, but it's looking like that 1.2 coefficient is going to decrease. As always, thank you for your time, and I hope this was helpful. And you can always follow us on social media or shoot us a message on an email to get more information or stay updated on current research projects. Thank you for your time.